everyone, welcome again in our laboratory. For this video, we'll be talking about acid-base titration. But before that, let me present our learning objectives and our conceptual framework. Without further ado, let's get it started.
Good day everyone, my name is Michael and today we will going to tackle about acid-base titration method. The Bronsted-Lowry theory, also called as proton theory of acids and bases, is an acid-base reaction theory which was proposed independently by Johannes Nicolaus Bronsted and Thomas Martin Lowry in 1923. The fundamental concept of this theory is that when an acid and a base react with each other, the acid form its conjugate base and the base form its conjugate acid base by exchange of proton, the hydrogen cation or H+. An acid-base titration is a method of quantitative analysis for determining the concentration of an acid or base by exactly neutralizing it with a standard solution of base or acid having known concentration. Acid-base titration is a way of determining of how much acid or base are present in the solution by determining size, volume of acid or base that completely reacts with the procedure. The analyte is prepared by dissolving the substance being studied into a solution. The solution is usually placed into a flask for titration. A small amount of indicator is then added to the flask along with the analyte. The reagent is usually placed in a burette and slowly added to the analyte and indicator mixture. So we have here the basic titration curve. The horizontal lines show the range of pH in which phenolphthalein, blue, and methyl orange-red change color. The middle lane represents the pKa while the two outer lanes represent the end or start of the color changes, the peak and light.
Thank you. Now we'll have and move on into acid-base titration calculations. Since titration is an analytical chemistry technique that is used to find an unknown concentration of an analyte, also called as titrant, by reacting it with a known volume of concentration or a standard solution that can also be called as titrant. Titrations are typically used for acid-base reactions or redox reactions. So the problem is 25.0 ml of aqueous sodium hydroxide solution of a known concentration was placed in the conical Erlenmeyer flask. Since we don't have an Erlenmeyer flask, then we will be using a measuring cup. The burette was filled to a 50 ml mark with 0.10 moles liter raised to -1 aqueous hydrochloric acid solution, but we don't have a burette, so we'll be using a 10 ml syringe as an alternative. The sodium hydroxide solution was neutralized when 20.0 ml of hydrochloric acid had been added. Now, we have to determine the concentration of the solution sodium hydroxide. First step in calculating is to write the balanced chemical equation for the reaction. So, HCl plus NaOH reacting to NaCl plus H2O. Second step, which is to identify what is given. So we have the volume of HCl, which is 20.0 ml, the concentration of HCl, which is 0.10 ml liter raised to -1, volume of NaOH, which is 25.0 ml, and the concentration of NaOH, which is unknown. It is because it is what we are going to solve. Third step is to check the data for consistency since volumes are given in ml but concentrations are given in moles per liter. So the volume of HCl from 20.0 ml will become 20.0 by 10 raised to -3 liters. Then the concentration of HCl will remain as is. Then the volume of NaOH from 25.0 ml will become 25.0 by 10 raised to negative 3 liters, then the concentration of NaOH will remain unknown. Now on the fourth step, which is calculating the moles of HCl. So we have the moles of HCl equals to concentration of HCl multiplied by volume of HCl, which is 0.10 multiplied by 20.00 by 10 raised to negative 3 will become as 2.00 by 10 raised to negative 3 moles. That is the answer. So we will proceed to the fifth step, which is to find the stoichiometric mole ratio of acid to base. So moles of HCl is to moles of NaOH will become 1:1 ratio. Now on step 6, which is to find the moles of NaOH. Since HCl and NaOH has this 1:1 mole ratio, so moles of NaOH is equals to moles of HCl, which is 2.00 by 10 raised to negative 3 moles at the equivalence points. Lastly is to calculate the concentration of NaOH. So to get the concentration of NaOH, you have to divide the moles of NaOH into the volume of NaOH, wherein the moles of NaOH is 2.00 by 10 raised to negative 3 moles, and the volume of NaOH is 25.0 by 10 negative 3 liters. So the answer will be 0.080 moles or 0.08 moles liter raised to negative 1.
Hello everyone, I am Christine Aloy and my topic is all about acid-base titration indicators. So what are indicators? So it is an auxiliary substance which exhibits color change at a particular stage of a chemical reaction. These indicators shows different colors at various pH levels, so we can easily determine the endpoint. These indicators also are either weak acid and weak bases. They will show different colors in ionized and unionized form. And also indicators are used in dilute solution form and selected on the base of the pH change near the equivalent point. So next is we will know what are the indicators used. So number 1 is strong acid versus strong base. In this type of titration, we can use methyl orange, methyl red, phenolphthalein, bromothymol blue, and phenolphthalein red. Second is we have weak acid versus strong base. In this type of titration, equivalence points appear above the pH, so the indicators that is being used are phenolphthalein, thymolphthalein, and thymol blue. Now number 3 is we have the strong acid versus strong base. In this type of titration, equivalence point appears below the pH. The indicators that is being used are methyl orange, methyl red, bromocrystal green, and the fourth one is we have acid as a weak acid versus weak base. The indicator that is being used is we have mixed indicators. So let's proceed to our experimentation. So I have here, which is our indicator, the mayana leaves. We also have baking soda with water, the vinegar, the lemon juice, and the tap water. First solution we gonna mix with our indicator is water with baking soda. The baking soda turns our indicator into green, which tells us it is a strong base. The next solution we gonna add to our indicator is tap water. Tap water turns our solution into very dark red. This tells us that the tap water that we tested is slightly basic but close to neutral. Vinegar is our next solution that is being mixed to our indicator, and it turns to a very bright red or pink color. This color change means that vinegar is acidic. Solution number 4 is the lemon juice. Lemon juice turns our solution into a very dark orange, which means that lemon juice is also acidic solution.